We are in our second day of Pre-Calc 4.4, graphs of sine and cosine, sinusoids. And like it says, review the basics of the unit circle. We did that so that we could start to see the patterns in our sine and cosine graphs. And then understand the graphs of y equals the sine of x and cosine of x. Hopefully you're starting to feel like, hey, I know where all that's coming from. And then today we need to hit some more of these transformations where we graph sinusoids and their transformations. We've already talked about amplitude. We have begun to speak about the period and how that's going to change. And then we still have the phase shift, which is the special name for a sinusoid wave that has a horizontal shift. And then the vertical shift of k. And we're leading to modeling periodic behavior with sinusoids. But where we finished was example 3. And I was running out of time in first hour. So there were a couple more things I wanted to introduce you to here as we talk about example 3. One of them would be when we look at our final graph, we want to think to ourselves, what was this 2 doing? And that 2, because it's with the x, we have to think opposites. This ended up being a horizontal compression. Factor of 1/2. So again, to us it looks like we're multiplying by 2, but because x is the naughty little one that's always the opposite of what we think is happening, instead it's really multiplying by a reciprocal of 1/2. And so that was a horizontal compression factor of 1/2. Then the other thing that I wanted to introduce you to was, how do we know where these graphs are going to start and where they're going to stop? And that's about the x-coordinate, where that's going to be at. So we know that normally the period for a sinusoidal wave is going to be from 0 to 2 pi. But that was when we were just talking about x. Cosine x, sine of x. This one isn't just x. This is 2x. So we have to see how is that going to change the period. And we had already talked about using the 2 pi over the absolute value of b to find the new period, but this is a way to know specifically where the graph will start and stop. And what we would do is solve for x by dividing all three pieces of our inequality. So 0 is less than or equal to x, which is less than or equal to, and then I wrote a 3 for a 2. It's late at night. There we go. And that's exactly what happened with our graph. Our graph began at 0, and the end of one period happened at pi. And that really helps it all come together when we start seeing, that we have an A, a B, an H, and a K, how all of this is going to work. So let's go to example 3, and they're both called example 3 here. Maybe we should have called one example 3.5. But we have determine the period for each equation and then graph 2 full periods of this. So when I look at y equals the cosine of 4x, I'm thinking to myself, well, this is going to be a horizontal compression factor of 1/4. Because again, we see it looks like it's being multiplied by 4, but it's actually divided by that reciprocal. So our horizontal compression factor of 1/4. Now if we want the period, we have to take 2 pi and divide it by the absolute value of b. So our period for this one will be 2 pi over 4, which is a period of pi over 2. And what we have to do is figure out, well, what's 1/4 of that? Because we have to break this up into those 4 equal pieces. Because this doesn't have a phase shift, we're going to start at 0. That's a given. So we start at 0, but we need to know, what should I add to that to get to the next spot? Now, just to make sure of those starting and stopping points, I know that normally cosine of x would be from 0 to 2 pi for one period. But this one has a 4x in there instead. So we have to divide everything by 4. And this shows us that the period for this graph is going to go from 0 to pi over 2, which we had figured out over here. So now, like I said before, normally we'd say, hey, let's divide our period by 4. But now we start to see that our period is a fraction. So probably easier to think of it as pi over 2 times 1/4, so that we can break this apart into those 4 equal increments. So we would get, by multiplying that by 1/4, top times top, bottom times bottom, pi over 8. So each of our increments, starting with 0, has to be pi over 8 units wide. So if we take our 0 and add pi over 8, we get pi over 8. So that'll be something we need to have labeled on our graph. Then we add another pi over 8, and that'll give us 2 pi over 8, which reduces to pi over 4. Then we'll add another pi over 8, and we'll remember that we had 2 pi over 8 plus 1 pi over 8, which is 3 pi over 8. And we'll add another pi over 8, and that will give us 4 pi over 8, which of course finally gets us to our pi over 2. Now why do I stop there? Because of what I did up here. I know that I'm supposed to start at 0, and I'm done when I get to pi over 2. So now I can figure out what my labels will need to be for my cosine graph. And what you have to do when you're going to label those increments is you have to use the biggest denominator that you have as you look at these increments. Otherwise, this is all going to be distorted. So I see that I have that pi over 8 piece here. So to spread it out a little bit, I'm going to go 2 of these little blocks for pi over 8. I don't want to squish it too much. I started off by using just 1 block for that pi over 8, but I don't want to squish it. So then I have pi over 8, and the next one that I had for an increment was pi over 4. And then I had 3 pi over 8. And pi over 2. And it says graph 2 full periods, so I could continue on if I wanted to fill the entire space. But what I have to do is make sure that I've got at least 2 full periods. And it's a good idea to do 1 positive and 1 negative. So let me get the blue to disappear here. And we'll go ahead and go backwards here with a negative pi over 8. A negative pi over 4. Negative 3 pi over 8, and negative pi over 2. I have everything labeled on the x-axis. Now I need to go after my y-axis, and I realize this doesn't have a change in the amplitude at all. My amplitude is going to be 1, because that's a 1 cosine of 4x. So I think I will go ahead and make 2 blocks. So basically each one of those blocks is going to be a half, but we'll go that way. Now I have to start putting my graph on there. So to do that, I have to think, well, is this cosine or is this sine? And this was a cosine graph. So I remember Kahala, which is cosine high. So it starts here. Cosine high, axis, low, axis, high. And then I want to follow that pattern backwards to the left. And then I want to make my smooth curve. And that gives a really accurate depiction of what we have going on with this graph that was a horizontal compression with a factor of 1/4. So if we were to compare this to our normal cosine graph that went all the way out to 2 pi for its period, we'd realize, well, if you take 2 pi and you divide it by 4, you're going to get pi over 2. And there is our new period piece that we have. So that graph just showing us what's going on with B, you know, having those horizontal stretches and compressions. There we go. Finally, I got that blue to turn off. All right, example 4. Both A and B at once. Oh, how will we do it? Well, it's not that hard to keep track of the fact that we've now got a new amplitude, and that's the height of the graph. And we're just going to have to be careful looking at the new period and the intervals and everything that we need when we're talking about a change in B. So, like I said, kind of the first thing you notice is that A is 3. So that's telling us we're going to have to go up and down 3. Might as well mark that on my graph right now. And then begin the process of trying to figure out, okay, where is this going to start and stop? How is all this going to come together? So amplitude first, period next. And our B value here is 2. The absolute value of 2 is 2. So our period will be pi. Now, in order for us to know where everything's going to fit together, we might as well stop and figure out where's the new start and stop pieces. And again, our B value here gave us a 2x instead of a 1x in the middle. So we'll divide it all 3 pieces by 2. And we'll see, oh, look at that. It's going to be from 0 to pi. Now, if you're thinking, why are we doing that when all of these are starting at 1 or at 0, you know, basically 0, 0 is what we use for our reference for all of these, because eventually we're going to see a phase shift. And this comes in super handy when you have a phase shift. So we're starting off with the basics, but it's going to get a little more difficult. So now what I have to do is say, well, it's going to start at 0. And I have to figure out my increments. And how I get those is by taking 1/4 times pi, or dividing pi by 4. So my increments have to be pi over 4. So I'll have 0 plus pi over 4, which is pi over 4. I mark that one to show, yes, that's got to be on my graph. I add another pi over 4, and that'll give me 2 pi over 4. Which is pi over 2. And so I add 2 pi over 4, and I add another pi over 4, and I have 3 pi over 4. And I add another pi over 4, and sure enough, I'm at pi. Again, you have to get into that habit of showing these steps, because it tells me you knew exactly what you were doing as you were working through this graph. So now they want 2 full periods again. We know we're going to start at 0 and go to pi, and we have what we should be labeling as we go through. So we've got a 0 and a pi over 4, and I'm looking at my denominators, and I realize, yeah, the pi over 4, the 4 is the biggest denominator. So we've got 0, pi over 4, pi over 2, 3 pi over 4, and pi. Again, I just need to show 2 full periods. That's the positive. I better show something in the negatives. So those are all labeled. Now, I want to get my graph on there, and I see that this is a sine graph, and I remember Sahala. Sine is axis, but now I stop and think for a second. Axis high, and my high is not a 1 because my amplitude was 3. So I have to go up to 3. axis low, going down to -3. Now I have the right side of that graph with my axis high, axis low, axis. And now I can go ahead and follow that pattern to go into the negative x values and make a nice smooth curve. Like so. So we do have our 2 full periods as we take a look at this. And again, if we were to think about the fact that the parent function is y equals the sine of x, we would realize that, yes, this should be 1 pi. You know, we've got that horizontal compression by a factor of 1/2. And I suppose I should write that down somewhere. So if you're thinking, well, why do we have that on there? Because we want to double check, you know, did our graph reflect what we know is supposed to happen? So you do want to think about those transformations of the vertical stretch of 3, which is pretty obvious when you see the a value. But you also put so much time into coming up with the increments that you need for your x's. It's always a good idea to just kind of double check when you get to this point and say, hey, is everything working out like I said it was supposed to work out? So we've hit a really hard objective there of, hey, we've got A's and B's, and we're going to continue on with that. So this has the A and B values together again. And example 4.5 says determine the amplitude and period for each equation and then graph 2 full periods. Well, pretty obviously, our amplitude is 2. And then we take our period equal to 2 pi over the absolute value of b. And we see this time, wait a second, my b value is a fraction. So absolute value of 1/2 is just going to give you 1/2. But we don't divide by fractions, we multiply by the reciprocal. So it's going to be 2 pi times 2 over 1. Hey, that's 4 pi. Yes, because this shows multiplying by 1/2. It's actually dividing by 1/2. And that means we're going to multiply by the reciprocal of 2. So our 2 pi becomes 4 pi. And again, we can see that by saying, here's what's happening to our x. It's not a 1x in the middle anymore. It's a 1/2 x. And of course, we would multiply all 3 parts of that by 2 to solve it. And we'd see it's going to be from 0 to 4 pi. Now, that makes those increments pretty swell. Because if we take 4 pi times 1/4, we get 1 pi. So our increments here are going to be by pi. 0 plus pi, and we'll just keep going. This one, you won't need to write them down. You know, 0 plus pi is pi. 0, pi, 2 pi, 3 pi, 4 pi. Because this wasn't fractions. You know, we can see very quickly and easily that our increment of 1 pi works out really, really nice. Now, let's get our labeling going. I know my a value is 2. Well, I'm just going to keep going with 1, 2, 3, 4, 5. Obviously, we have a little room here. We could have stretched that out and maybe used 1/2 for each of those increments, but we don't have to. And then I have to make sure that my x's are labeled in terms of pi. So 1 pi, 2 pi, 3 pi, 4 pi. And yeah, we have a lot of extra space on this graph. But let's make sure we have 2 full periods, so let's go backwards. Negative 1 pi, negative 2 pi, negative 3 pi, and negative 4 pi. Now we have cosine. and cosine is Kahala. So cosine is high, and I'll have to start at 2. Axis, low, starting at -2. Axis, high. And that's because my amplitude was a 2. And now let's follow that pattern backwards. And I hope right now some of you are saying to yourself, I like graphing sinusoids. This is not much trouble at all. That means we've done enough of these that you're starting to feel comfortable with them, which is exactly what I'm going for. So there we have it. And with this one, I'd want to stop and think, oh yeah, this one would have been a horizontal stretch factor of 2. So twice as long as 2 pi is 4 pi. Yeah, that represents what was going on here. I've got it. And that one is finished. Again, my hope is you're saying to yourself, piece of cake. I know what I'm doing here. And now we're going to talk a little bit about frequency, which is another thing that you hear a lot when people are talking about sound, especially radio, if anybody out there still listens to the radio. The frequency of the sound. So frequency and amplitude are really important with the sound waves, and frequency of the sinusoid f of x equals a sine of the quantity b times the quantity x minus h plus k is, well, how do we find that? It is the absolute value of b divided by 2 pi. Now, I am really hoping that you are looking at that and saying, well, that's just the reciprocal of period. Well, of course it is. So all we have to do is flip it upside down. And similarly, whether or not you're talking about sine or cosine, notice it's the absolute value of b over 2 pi. So what are we talking about here? What's frequency? Well, like it says graphically, the frequency is the number of complete cycles that the wave completes in a unit interval. So in the real world, pardon me, this is referred to as the wavelength. And in real life, it is the periods that our graph oscillates through in 1 second. So that's what it really is in real life when you talk about sound. The periods that our graph will oscillate through in 1 second. So frequency, they're going to ask us to do this. And like I said, you couldn't finish the day 1 assignment because there were some questions there about frequency. So we need to know how to answer those. Find the frequency of a sinusoid. Find the frequency of the function and interpret its meaning graphically. All right, well, absolute value of b divided by 2 pi. Well, look at that mess. I need to separate out b. It's not too hard to do. It's 2/3. So if we rewrote this, it would be 4 sine of 2/3 x. So my b value is 2/3. The absolute value of that is 2/3. And I have a 2 pi down there. But again, it's a fraction, and we know that we don't divide fractions. Multiply by the reciprocal. So 2/3 times 1 over 2 pi. We can do a little cross-canceling, reducing here by taking those 2's out of there. So we'll have a 1 over 3 pi. So that is our frequency. But what does it mean? Well, you read it off like this. This graph will have 1 full cycle for an interval of length 3 pi. 1 full cycle. Notice how we have this 1 right on top. That's what we need. 1 full cycle for an interval of length 3 pi. The a has absolutely nothing to do with the period or the frequency, which is the wavelength. Now let's take a look at B. So again, we're trying to figure out the frequency, absolute value of B divided by 2 pi, because the frequency is just the period upside down. And this time we see that our B value is a 3. But wait a second, I want this to be easy like the last one. I want a 1 on the top. So I think to myself, right now, that's the same thing as 3/2 times 1 over pi. But I want a 1 up there instead of having that 3 and the 2. So I have to remember that multiplying is the same thing as dividing by the reciprocal. Now, we don't think that way most of the time, but what we would have is 1 divided by 2/3 pi. Now, if you think about that forwards, it makes perfect sense because we wouldn't divide by 2/3. We'd multiply by the reciprocal, which is 3/2, and that would make it work. But this is what works to talk about frequency, having a 1 on the top. So for this one, we say we'll get 1 full cycle for an interval of length 2 pi over 3. And we've got it, because 2/3 pi is the same thing as 2 pi over 3. And there it is. So frequency, what you want to get is a 1 in your numerator. So you can say, hey, this is 1 full cycle, and then your denominator will tell you the length of that cycle. So now, let's see what we can do moving forward, because we've done a lot of A and B, and now we've talked frequency. And in example 6, it says, hey, did you ever notice you could get one sinusoid from the other by a phase shift? Remember, with sound, phase shift is the fancy name for the horizontal shift. So I look at this and I think, all right, and I can do something here that you're not going to be able to do in your paper. And that is draw over the top of one of these and then think, okay, this is the sine graph. If I just move that to the left, it matches cosine perfectly. Well, move it how far to the left? Well, this was 3 pi over 2 at its lowest point, and this is pi. So what's the difference from 3 pi over 2 to pi? Well, if you take 3 pi over 2 and you subtract 1 pi from that, you're going to have pi over 2. So it's a phase shift of pi over 2 units. And the reason that happens is because sine and cosine are complementary functions. So down here by the star, we see sine and cosine are complementary functions or cofunctions of each other. They only differ by a phase shift of pi over 2, which is 90 degrees. So A says, write the cosine function as a phase shift of the sine function. So if we need the cosine of x, what do we have to do to the sine function to get it? And that's what I just did up here. Here was the sine function, and I had to move it pi over 2 units to the left to make that happen. So then I remember that anything with the x has to look the opposite of what I'm thinking. Because left we would normally consider negative, but minus a negative would give you a plus. So that's how that works. Now, how about the other way? So if I have the cosine function, how could I move that so that it would match up with the sine function. So if I go pi over 2 units to the right, I'll have it where it needs to be. So the sine of x equals the cosine, and we moved it to the right, so it's going to look like x minus pi over 2. Because a right movement to us seems positive, or again, think of it as an x minus in our formula, just like we have in our generic formulas for A and B, right down here. So there it is. And as we see, it says the phase shift is h. Of course it is. It's just the fancy name for that horizontal translation. So this is the horizontal shift. The phase shift is a horizontal translation of the graph along the x-axis. So again, the x is the naughty variable that always behaves the opposite of what we see. So if it's positive, we're going to shift to the left. It's going to look like x plus something. And if it's negative, you shift to the right. So x minus something is actually a right movement. To find the new period and 5 critical points to graph the sinusoid, follow these steps. This is going to be important because on top of what we have to keep track of for A and B, we'll also have to keep track of what's going on with H and K. So let's see. It says find the new period, the new starting point, and the 4 critical points to graph. F of x equals 3 sine of the quantity x minus pi over 2. Well, let's start by figuring out where those starting and stopping points are going to be, because like it says here, our new way to find this is figuring out what's going on with x. But in this case, we've got a 1 for b, and really it's just the x minus pi over 2 that's going to affect what we have for that increment and starting place. So 0 is less than or equal to, and then we know normally this graph would go from 0 to 2 pi, but now it's not just x, it's x minus pi over 2. So what we would have to do is add pi over 2 to all 3 pieces of our inequality. Well, in case there was any question about where this graph was going to start, we can see 0 plus pi over 2 is now pi over 2. And of course it is. That was the phase shift. And then we have 2 pi plus pi over 2. Well, you need a common denominator. So we have 2 pi over 1. We need a common denominator of 2. We multiply by 2 on the top and the bottom. So we have 4 pi over 2 plus 1 pi over 2. Which is 5 pi over 2. Go over to the left where they wanted us to find the period, and the period is always 2 pi over the absolute value of b. Not the frequency, the period. So our b value here is a little 1. So the period is still 2 pi, and that's going to help us figure out our increments that we need. So if we take a fourth of 2 pi, we'll get pi over 2. Now, the good news is, we know where we start this graph. It starts at pi over 2. And now we know that what we have to do for our increments is have them be pi over 2 units long. So that means we don't have to do any fancy common denominator business. Pi over 2 plus pi over 2 is 2 pi over 2, which is pi, plus pi over 2 would give us 3 pi over 2. Plus pi over 2 would give us 4 pi over 2, which is 2 pi. And 4 pi over 2, for some reason I wrote a pi over 4. It's getting late. And let's add another pi over 2 to that. 4 pi over 2 plus pi over 2 is 5 pi over 2. And we can see, hey, this is going to work. We're going to start at pi over 2. We're going to end at 5 pi over 2. That's exactly what we need. So let's see if we answered everything they have here. Find the new period. Did that. 2 pi. The new starting point. Well, the new starting point, because this is sine, is going to be pi over 2, 0. Because remember, sine starts at 0. And our new stopping point will be 5 pi over 2 at 0. Because its sine is axis high, axis low, axis. So we'll be back to 0 with that one. And the 4 critical points to graph, we've got those. That's our pi over 2, our pi, 3 pi over 2, 2 pi, and 5 pi over 2. So what we're doing here is we're following the directions that they have, putting anything that's affecting the x in between our original period for sine or cosine. In this case, it was sine, and we're solving. So solving this for x gives you your new starting point and stopping point for one full period, and then just divide that region into those 4 equal increments. And the part that was really important about that is taking the period times 1/4, because that'll tell you how wide those increments have to be. Now, example 6.5 says combining a phase shift with a period change. Ooh, a couple things at once. Construct a sinusoid, so a cosine or a sine, with a period of pi over 5 and an amplitude that goes through the point 2, 0. So, how are we going to make that happen? Well, I like that that's at 0 at 2. To do that, it would need to be a phase shift of 2 to the right. It would also have to be a sine wave for that to happen, because remember, the sine wave is going to start graphing at 0. Cosine starts at 1. So it's like I'm using that as my new starting point. And it said that we need to construct it with a period of pi over 5. Oh, so 2 pi over the absolute value of b has to come out to be pi over 5, huh? Well, let's figure out what it would be for b. So we could cross multiply and get the absolute value of b times pi equals 5 times 2 pi. So the absolute value of b times pi equals 10 pi. And now I don't think there's any mystery here that we're going to get 10 for our absolute value of b. And you could divide both sides by pi if it drives you bonkers that we stopped there. But we're definitely going to have a 10 in the position for b. Let me make a little bit more room here for that. Now what else? It needs an amplitude of 6. That's going to go in front. So we started this by actually building from the point 2, 0, and then using what they gave us for the period to figure out what b is, and finally using the amplitude that they gave us, and we have it. So you could just put a double set of parentheses right there. Let's call it a function. Let's do f of x. Or, better yet, distribute the 10, depending on what you wanted to do with it, you know. And what they wanted us to do was write it. So writing it looks a little neater to just have the one set of parentheses. We'd take it both ways. You know, it's going to work both ways. But you have to make sure that you make the period match what they want and the amplitude match, and it has to start at the right spot. And because it was starting at 0, it was much easier for me to take our sine curve and move it over 2 units than it would be to move the cosine curve over so that it would match at 2 units. So when it says sinusoid, you get to pick. Am I going to use sine or cosine to do this? And let's go ahead and go through example 7. All right, so for example 7, we want to find the amplitude, period, and phase shift of this equation and graph it. And I see that it's going to be a cosine. and the absolute value of A will be 1/2. So this has an amplitude of 1/2. It already has me thinking, you know, maybe I better space this one out a little bit farther. So every 2 of these, which would give me a halfway point of 1/2 for each one of those little blocks. So there's our amplitude at 1/2. And the period is 2 pi over the absolute value of B. Well, B is 1. You know, again, B is supposed to be with the x, so if there's nothing there, that's a 1, and that's going to be 2 pi divided by 1, which is just 2 pi. Now, the phase shift. The phase shift, we see that it says x plus pi over 2, but that tells us our phase shift is actually going to be negative pi over 2. So we're going to be transforming this pi over 2 units to the left. So that's our horizontal shift called the phase shift, pi over 2 units to the left. All right, we need a starting and a stopping point, and then we'll have to figure out our increments. So we had normally for cosine 0 to 2 pi, but this one has a x plus pi over 2 attached to it. So we're going to have to subtract pi over 2 from all 3 pieces. And if we take 2 pi, and that's 2 pi over 1, and we subtract a pi over 2, we need a common denominator. So we'll get 4 pi over 2 minus pi over 2, which is 3 pi over 2. And that will be where we are supposed to end one period. And this verifies that, yes, in fact, our phase shift is going to start at negative pi over 2, which is great. That's what we needed. So now I need to find a fourth of my period, which was 2 pi, which will be pi over 2. Now, I know my new starting place is negative pi over 2. I got that from my inequality. And I know that my increments have to be pi over 2 units apart. So I'm going to have to add a pi over 2, and that brings me to a very nice number, which is 0. And then I'm going to add another pi over 2 and get pi over 2. Add another pi over 2 and get 2 pi over 2, which is pi. Add another pi over 2 to my 2 pi over 2, and I will get 3 pi over 2. Now let's count off the ones that I have in the pseudo rectangles here. And we have 1, 2, 3, 4, 5 of them. And it starts at negative pi over 2 and it ends at 3 pi over 2, which is exactly what we needed. So now what we'll do is we'll go ahead and put those increments on there. We want to look for that biggest denominator that we see, and it is a 2, so we definitely want to go with a negative pi over 2. I'm going to space it out a bit. So there's my negative pi over 2, and then 0, and then I've got pi over 2, 3 pi over 2, just trying to get this close to where the lines are, but it's not very dark. Pi over 2, 3 pi over 2, 4 pi over 2. Let me stop here for a second. As you're thinking, well, why are we doing more? Remember that we have to have at least 2 full periods whenever we graph. So right now we have 1 full period from negative pi over 2 to 3 pi over 2. But if I need 2 full periods, I want to go a little more in each direction. So 3 pi over 2 plus pi over 2 is 4 pi over 2, which is 2 pi, 5 pi over 2. But I also want to get some of the negatives in there, so I should go backwards. Negative pi over 2 minus pi over 2 would be negative 2 pi over 2, which is negative pi. Harder and harder to see these lines. And then negative 2 pi over 2 minus pi over 2 would be minus 3 pi over 2. Negative 4 pi over 2 would be negative 2 pi. And negative 5 pi over 2. So this way I'll make sure I have more than my 2 periods going. But I have a phase shift that I have to remember to do. And that phase shift was that I needed to move this graph pi over 2 units to the left. And I might forget that. So one of the things that we can do is we can write a helper line, which is going to be dashed or dotted. And if we need it, we could put it right here at pi over 2 so that we remember this graph does not start at 0, 1, where cosine would normally start. So I think about Kahala. I've got everything labeled now, and I need that Kahala to help me out. And I realized cosine starts high, but our amplitude was only 1/2. So my new starting point is at the negative pi over 2, but 1/2. I have to make sure that that's going to be a cosine graph, which starts high. So high, axis, low, going down to negative 1/2, axis, high, axis, and then following the pattern backwards. And making a nice smooth curve. And I hope you're saying to yourself, well, that's not too bad either. You know, we had an amplitude that changed here, and we had a phase shift that changed. But if we just keep track of everything, then we should be fine. Let's do one more of these, and then I'm going to call it a night. Y equals negative 1/2 sine of the quantity x plus pi over 4. So we want to determine the amplitude, which again has nothing to do with the negative. The negative is a reflection, but we don't want to forget about that reflection. So let's put reflect over the x-axis so that we don't overlook that. But our amplitude is 1/2 again, so still kind of a short little graph. And then we have to tell them about the period. 2 pi over the absolute value of b for the period. And again, our b value in this one is just a 1. So that's going to be 2 pi. They wanted to know about that phase shift. So our phase shift this time is going to be a negative pi over 4. Because remember, this was all about x minus h right here in this piece. Well, let's start finding stuff. So let's figure out our new starting and stopping point. And this is a sine graph, and so what we need to do is say, well, it's normally from 0 to 2 pi, but I have to subtract pi over 4 from all 3 parts of my inequality. So I need to have 2 pi in terms of fourths, which would be 8 pi over 4 minus pi over 4, which will give you 7 pi over 4. So there's my new start and stop. I'm going to start at negative pi over 4, and I need to finish up at 7 pi over 4. Let's go ahead and put our y's on there. Ugh, I really don't like that that blue line is right in the way there. Let's see. Can I move my graph? So that's not so awful. There we go. That's better. Now, I'm going to go 2 units for a 1 again. That way I can make sure I remember that 1/2 piece is nicely organized here. But I don't want to have to write all of those fractions on there. It just becomes busy work, and you won't be able to read it if I put 1/2, 1, 3/2, 2. So better to just space it out so it would be obvious what's going on. And now I need to do that whole labeling of the x's, and I know I'm supposed to start with negative pi over 4 thanks to my inequality. And now I have to figure out what are my increments supposed to be. And I remember my period was 2 pi, so if I take 2 pi times 1/4, which we've had to do a lot, we get pi over 2. So we'll have to add pi over 2, which means a little bit of thinking about common denominators, but it's not too hard. You've got a 2 down here in the bottom, so you'd multiply the top and the bottom by 2. Negative pi over 4 plus 2 pi over 4 would give you 1 pi over 4. Plus another 2 pi over 4 would give you 3 pi over 4. Plus another 2 pi over 4 would give you 5 pi over 4. plus another 2 pi over 4 would give us 7 pi over 4. So notice I didn't do the common denominator thing every time, starting to do more of the fraction stuff in the head. If you can, try and do that. If you can't, then yeah, you write it down each and every time as 2 pi over 4 so that you can get those increments. So now, pretty obviously, even though my increments were in pi over 2, my labels need to be with that biggest denominator, which is going to be the 4. And we will get to a graph where that becomes really important. We're just not there yet. So think about why I keep saying we need that biggest denominator to go through this. This is a good graph for us to actually talk about this piece and taking care of the distortion. So what I want to do is think about how my pi over 4 would fit into everything that I have here. So I'm going to put a negative pi over 4 right here and a positive pi over 4 in this spot. And the reason that I'm doing that is because I want this increment to be 1 pi over 4, and I don't want to distort my graph. So now the next one that I would get to would obviously be 2 pi over 4, which is pi over 2. But I don't need to label that one. The next one that I need to label here is going to be 3 pi over 4. So 1 pi over 4, 2 pi over 4, 3 pi over 4. And then I'll go back and erase that increment that was in between, if the blue marker will let me. There we go. And that's how I'm not going to have this graph distorted. Each one of our x intervals is going to be 1 pi over 4, but I'm only labeling the ones that I know I need to graph so that I don't accidentally put my points in places they don't need to be. So then another 2 of these would give me 5 pi over 4, and another 2 of these would give me 7 pi over 4. And again, I want 2 full periods, so I think about the fact that I'd add another 2 pi over 4 because we had pi over 2, and that would give me 9 pi over 4. And it just kind of naturally follows anyway from looking at those odds. We have 1 pi, 3 pi, 5 pi, 7 pi, 9 pi. And then we'll go backwards. So negative pi over 4, negative 3 pi over 4, negative 5 pi over 4, negative 7 pi over 4, and negative 9 pi over 4. I had a phase shift, and my phase shift was a negative pi over 4. So negative pi over 4 is left. I'm going to put my little helper line on here, keeping in mind that any helper lines are always dashed or dotted. They're not actually a part of the graph. And then I think, okay, sine. Sine is Sahala, axis high, but not this one, because this had a reflection over the x-axis. So with this one, where I would normally start axis and high, I'm going to change that because my high points become my low points, and it will be axis low. Now notice, that is not on the y-axis. That's why it was important that I used those increments on the boxes themselves, along with my labels, to make sure that this is not distorted. And so this starts the new pattern for me. So instead of Sahala, we've got sine is axis low, axis high, axis low. And that was our negative 1/2 that's doing that reflection over the x-axis, and then an amplitude of 1/2. And follow the pattern backwards and connect that up into a nice smooth curve. Got a little away from me there at the end. And we have it. So we're starting to see that depending on what we're doing, we could mess up this graph and really distort it if we don't pay attention to what our denominators are. And I know I went a little bit over, but I'm hoping you stuck with it because I really felt like things were maybe getting a little bit too easy for you. So A and B here are definitely a little bit more challenging, especially B. So now you'll definitely be able to finish up 4-4 day 1. And again, it's late. I didn't look at the 4-4 day 2 assignment, but if you encounter anything in the 4-4 day 2 assignment where you're thinking, we didn't cover that yet, you can stop. But I'm pretty sure we're going to be totally okay now because I've discussed the frequency and we've talked about stopping and starting and all of that. But if you get to the point where you're saying to yourself, oh, this has vertical shifts and we haven't done vertical shifts yet, well, then stop. I don't want you to go on, especially on something brand new, if you're feeling like, hey, she hasn't taught us this yet. So that will be what you need to take care of. Have a great weekend.